From space, Earth looks peaceful, a blue and white marble suspended in the vast darkness. Its swirling clouds and deep blue oceans give the impression of calm and stability, a serene oasis in the cosmos. But beneath our feet, immense energy is always at work. The ground we walk on is alive with hidden forces, volcanoes simmer, geysers erupt, and the Earth trembles with the power of shifting rock. The crust we live on is astonishingly thin, like the skin of an apple separating us from a seething, molten interior. Just a few dozen kilometers thick, it floats atop a churning sea of magma and rock, constantly shaped by the heat below. This outer shell is fractured into tectonic plates, floating atop the slow-moving mantle. These plates are like giant puzzle pieces, their edges grinding, colliding, and pulling apart in a never-ending dance. Heat from the core drives these plates, shifting continents and ocean floors at a pace as slow as fingernail growth. Over millions of years, this slow movement has redrawn the map of our planet again and again. Over eons, continents collide, oceans open and close, and mountains rise and erode. The landscapes we see today are just the latest chapter in a story billions of years in the making. We are passengers on these restless rafts of rock, our landscapes shaped by their constant motion. Every valley, ridge, and plain is a testament to the forces that never sleep beneath us. The evidence is everywhere: the towering Himalayas, the deep scars of African rift valleys, and the fiery eruptions of Pacific volcanoes. These are the visible marks of Earth's ongoing transformation. All are snapshots of a planet in flux, caught in a moment of its endless evolution. Our world is never truly still. Understanding this deep planetary pulse is key to understanding our world. Scientists study rocks, monitor earthquakes, and map the shifting crust to unlock the secrets of Earth's restless nature. Earth is not just a stage for life, but a living, ever-changing entity. Its surface breathes, shifts, and transforms, reminding us that we are part of a dynamic, interconnected system, one that continues to shape our past, present, and future. Plate tectonics explains how Earth's crust is split into massive plates, drifting atop the mantle's convection currents. There are 7 major plates and many smaller ones, all in slow, relentless motion. Where plates meet, Earth's most dramatic events unfold. At divergent boundaries, plates pull apart, magma rises and new crust forms, like at the mid-Atlantic ridge. At convergent boundaries, plates collide. Oceanic plates dive beneath continents, forming deep trenches and volcanic arcs. Transform boundaries like California's San Andreas Fault see plates grind past each other, building up strain. When that strain is released, earthquakes shake the surface. These boundaries are the planet's fault lines, zones of creation and destruction. The tectonic dance never stops, constantly reshaping our world. Every mountain, trench, and quake is a step in this ancient choreography. Tectonic collisions are the master sculptors of our planet's grandest features, shaping the very face of the Earth over millions of years. These immense forces, hidden deep beneath our feet, are responsible for the breathtaking diversity of landscapes we see today. When two continents collide, neither is willing to yield or sink beneath the other. Instead, their edges buckle, fold, and thrust skyward, creating colossal mountain ranges like the Himalayas. These towering peaks are a testament to the relentless power of plate tectonics, rising higher each year as the collision continues. In other places, oceanic plates dive beneath continents in a process called subduction. This action carves deep ocean trenches and fuels chains of volcanoes as seen in the mighty Andes. Here, molten rock rises to the surface, building new mountains and reshaping the land with every eruption. Where plates pull apart, the Earth's crust stretches and cracks, forming rift valleys like Africa's Great Rift. Over time, these rifts can widen and fill with water, eventually giving birth to new oceans and dramatically altering the map of our world. These geological processes unfold at a pace almost too slow to notice, yet their effects are profound and far-reaching. Mountains gradually rise, valleys deepen, and entirely new land emerges from the depths, forever changing the landscape. But not all changes are slow. Sometimes the Earth's energy is released in sudden bursts, earthquakes that can reshape entire regions in moments. These powerful events trigger landslides, alter river courses, and remind us of the planet's unpredictable nature. The ground beneath us is alive and ever-changing, shifting and moving in ways we often cannot see or feel. Every landscape, from the tallest mountain to the deepest valley, is a work in progress, an evolving masterpiece sculpted by forces deep within the Earth's core. The restless movement of tectonic plates ensures that nothing on the surface remains unchanged forever. Erosion, uplift, and shifting ground are constant reminders of our planet's dynamic nature. Our world is a living canvas, its features continuously redrawn by the invisible hand of tectonic power, creating new wonders for future generations to discover. As we explore and marvel at these ever-changing landscapes, we are witnesses to the ongoing transformation of our planet, a story written in stone, unfolding beneath our very feet. For centuries, Mount St. Helens stood as a tranquil, symmetrical peak, its snow-capped summit rising gracefully above the forests of Washington state. Locals and visitors alike admired its beauty, never suspecting the dramatic transformation that would soon unfold. But in 1980, everything changed. Deep beneath the surface, magma began to accumulate, pushing upward with relentless force. The mountain's north face started to bulge outward, a silent warning of the power building within. Cracks appeared along the slopes, and the landscape grew increasingly unstable, hinting at the catastrophe to come. On the morning of May 18th, a moderate earthquake struck, shaking the mountain to its core. In an instant, the entire north face gave way, triggering the largest landslide ever recorded in human history. The earth itself seemed to move, forever altering the landscape. The sudden collapse unleashed a violent lateral blast, hurling superheated gas, rock, and ash across the land. Entire forests were flattened in seconds, and a massive ash cloud billowed high into the sky, darkening the region for miles around. For 9 relentless hours, the eruption raged on, spewing ash and debris over hundreds of square miles. What was once a lush wilderness was transformed into a barren wasteland, the landscape forever scarred by the mountain's fury. More than 1,300 feet of the summit vanished in the chaos, leaving behind a vast, gaping crater. The mountain's familiar profile was gone, replaced by a stark reminder of nature's unpredictable power. The eruption was a stark reminder that the forces shaping our planet can act in mere moments, reshaping entire landscapes and altering the course of history. Yet, Mount St. Helens was not destroyed. Instead, it was transformed, entering a new geological chapter. Over time, life began to return and new features emerged from the ashes, showing the resilience of nature. Scientists flocked to the site, eager to study the aftermath. The eruption provided invaluable lessons, deepening our understanding of volcanic hazards and helping to improve early warning systems for communities living in the shadow of volcanoes worldwide. The story of Mount St. Helens stands as a vivid example of Earth's restless energy, a reminder that our planet is alive, dynamic, and ever-changing. Even in the wake of destruction, the planet is always remaking itself, offering hope and renewal in the most unexpected places. Yellowstone National Park is a landscape of beauty and danger, sitting atop a massive supervolcano. Its geysers and hot springs are surface signs of a vast, simmering magma chamber below. The last super eruption 640,000 years ago created the park's giant caldera and ejected unimaginable volumes of ash. Today, geysers and hot springs act as safety valves, releasing heat and pressure from below. The park's vibrant pools teem with heat-loving bacteria, thriving in extreme conditions. Yellowstone's beauty is inseparable from its volcanic power, a reminder of the forces shaping our world. The ground breathes, earthquake swarms rumble, and the sleeping giant beneath commands awe and respect. Scientists vigilantly monitor active volcanoes like Mount St. Helens and Yellowstone. Seismometers detect tiny earthquakes, often the first sign of magma on the move. GPS and satellite radar track ground swelling, revealing magma chambers filling or emptying. Gas sensors measure volcanic emissions, signaling fresh magma's approach. By combining seismic, deformation, and gas data, scientists build a picture of volcanic unrest. Early warnings save lives, as seen before Mount St. Helens erupted. The goal isn't perfect prediction, but risk reduction and preparedness. Our ability to read Earth's signals is vital for living safely on a dynamic planet. Volcanic eruptions are both destructive and creative, shaping the land and nourishing life. Ash from eruptions, rich in minerals, creates fertile soils, reason enough for people to settle near volcanoes. The slopes of Vesuvius and Indonesia's islands thrive thanks to volcanic nutrients. Volcanoes build entire landmasses. Hawaii's islands are the peaks of underwater volcanoes still growing today. The process continues with new islands forming as plates move over hotspots. Volcanic forces also shaped our atmosphere and oceans, making life possible. Every eruption is part of a cycle, destruction followed by renewal. When we see Yellowstone's wonders or Mount St. Helens' recovery, we witness this duality. Earth is not static, but a world in constant motion and transformation. We are privileged to be part of its ongoing story.